Right, this is test number 7 from the series note, and this test is mainly based on graphs. Right, as you know, the graphs is a very crucial part when it comes to understanding physics. So the purpose of graphs is, when you're doing equations, the meaning of those equations can be represented graphically using a graph. So you have a better understanding of the variations, and you can see the variation, how those equations and variables behave. So in the exam, they are going to ask many questions in regards to graphs, right? So this is one of the most important part when it comes to physics. So this test is going to help you immensely to deepen your understanding of graphs. Right, let's do the first question. Gradient of the graph shown below is. So they have given a graph, right? For this question, you know that when it comes to graphs, there are two key concepts. One is intercept of the graph. Intercept everyone can understand, because that is just the point which intersect the y-axis, right? So mainly what the types of graphs you get, especially for experiments, is y equals mx plus c graphs. So this c represents the intercept. This is all level stuff, right? Then this m, that is the gradient. So you need to have a in-depth understanding of gradient and the intercept. Intercept is easy to understand, but gradient is something that some students find difficult to understand. But here, once we are done with this, you will have a in-depth understanding of gradient as well, right? So m is the gradient, c is the intercept. Then we have these y and x, right? Y means these words are important, right? Y is dependent variable. X is independent variable. So whenever you get a independent variable, you have to show it as x, and y is dependent variable. Dependent variable means this variable always depends on this x, right? For an example, let's say this is a simple example. Let's say this equation s equals ut. Let's say a vehicle moving to this side at constant velocity 2 meters per second. Then this u is 2, right? Then this time, there's time. You can form this equation in this way. S can be considered as y, t can be considered x. Then the gradient is going to be 2, right? So based on these, you can just draw a graph like this, which goes through the intercept. You can see the intercept is 0. You can see that goes through the 0, right? So time is the independent variable. Why do we call that? Time just flows, right? Nothing affects time. Time just flows. So that we call that independent. It does not depend on anything. But as the time goes on, the displacement s increases. It always increases with time. So displacement, this s, is always dependent on this independent variable. So this is called independent and this is called dependent, right? So those terminologies are really important to understand, right? So whenever you are doing an experiment, you have to clearly understand what the independent variable is and what the dependent variable is. So that's the first thing, right? Then you can mark them in a graph like this. So usually we put the dependent variable here as the y-axis. Here you have the dependent, right? For the x-axis, you have the independent variable. So usually that is the standard when you are drawing graphs, right? So these are very important when you are doing experiments. If you don't understand these things, you are doing experiments just without having a good understanding of those experiments. So each and every experiment, almost all the experiments, there's going to be a graph, right? Involved with a graph, right? So we know that what intercept is. So in this question, what they ask is gradient, right? So how do you find the gradient of a graph? So already they have given two coordinates. So Q, this point has two x and y coordinates. Let's say x2, y2, x2, y2. Here you have x1, y1 coordinates, right? Let's say like that. So first one is x, other one is y, x, y coordinates. So once you are given coordinates, in order to find the gradient, this is what you have to do. Gradient is actually tan value of this angle, right? Tan value of this angle. So what you have to do is you need to divide this height by this height. That's what you have to do. So you can see this height is y2, right? y2. This height is y1. So to find this height, it is y2 minus y1. Then this height, how do you find that? It is related with x. This is x2. See that? x2. This one is x1. So what about this height? x2 minus x1. Right? So this side is x2 minus x1. Now this gradient is equal to tan alpha. Alpha, tan of this angle. Right? So tan alpha is what? Opposite divided by adjacent. So y2 minus y1 divided by x2 minus x1. Right? So these are simple steps. So here, this is how you find the gradient. So it is simple as that. See, so usually we take linear graphs when it comes to experiments, right? Especially in A levels, we get linear graphs because it is easy to deal with linear graphs. Because in a linear graph, gradient is a constant. Gradient is a constant. So that's why we use linear graphs mostly when it comes to experiments. I think you have done several number of experiments, right? Okay. Okay, so now you just have to substitute values. So here y2 is what? 270. y1 is here y1 80. Divided by x2 minus x1. x2 is 480. x1 is 130. So when you simplify that, you have to simplify that, right? You don't use calculators. You can use a logarithm book if you want. Otherwise, I think you won't have to use logarithm here. Never use calculators, right? Only use logarithms if the simplification is complicated. Otherwise, you'll be helpless when it comes to the exam. Right. So I'm just going to write the answer here. So the correct answer is 0.543. So the correct answer is first one, right? First one is the correct answer. Right. Second question. The most appropriate two xy coordinates to get the gradient of the graph are, right? Right. So let's say you did an experiment and you have a set of data in a table, right? I think you are familiar with those x and y coordinates. So you have data in a table. Then you have to mark those data as xy coordinates on the graph. Then you draw the best fitted line. You draw the best fitted line. So that is what you do. So why do we draw graphs when it comes to experiments? let's say you just had you did a one experiment, right? Without changing anything, you just did you did the experiment once. So you only have two data there. Let's say 2 and 3. But this is not that accurate. Why? Whatever the property you are going to measure is only based on just a one coordinate. So this is less accurate. Okay. So what do? We do the same experiment multiple times by changing some variable, right? Then you get a graph. So once you get a graph, this graph is determined by a bunch of variables. So in the experiments you have, usually you have to take about 6 coordinates, right? So 6 coordinates determines the one property. So it is going to be more accurate. So obviously it is going to be more accurate, right? So 6 coordinates are saying about the one thing. It is more accurate than doing the experiment just once and taking values. You can take values only using just a one coordinate, but it is less accurate. So that's why we have to draw graphs by doing the same experiment multiple times in order to get these coordinates, right? So that's the reason why we need graphs when it comes to experiments, right? But in this question, what they ask is, so let's say you have drawn the graph now. On the xy Cartesian plane, you have drawn the graph. Then you need to get the gradient, right? The question they ask is two coordinates most appropriate in order to get the gradient, right? So there are some rules, and these rules are just rules when it comes to graphs. So you have to strictly follow these rules. So in the exam, A-level exam, so you can see you have a graph sheet. So there are rules everywhere, right? There are small squares everywhere. But once you follow these rules correctly, there can be only two coordinates that you can get to get the gradient. Okay? So these are the rules. The number one is you cannot choose two coordinates like this. Let's say this one coordinate here, another coordinate here. Those coordinates must be on the graph, right? On this line. One coordinate here, one coordinate here. These are very close. Then it causes, so the rest of the graph is useless there, right? So it doesn't represent the data set we got. So it is less accurate. Therefore, in order to find the gradient, you have to get two coordinates that are at furthest away from each other. That's the first rule, right? So those 2 points represent the whole set of data for the experiment. Furthest possible two coordinates. So that is the first rule. Furthest away. Right? Furthest away. That's the first thing. Second one is you have to choose the coordinate that intersects. So in the square graph, I mean in squares, there's these rules, right? Horizontal rules and horizontal lines and vertical lines. So this graph must intersect through a point like this. So you can choose the 2 points. So you can see this intersects at 30 and 60. Here 39, 31. So exactly this graph has to go through such a point. It cannot go like this, right? Let's say the graph is like this. Vertical line is like this and horizontal line is like this. Then the another rule is here. So it doesn't go through exactly through a intersection like this. So you cannot choose this point as a coordinate, right? It should be, the graph should go through those crossing, one of the crossing. This is a must there. Crossing, right? It has to go through a crossing. So you just have to follow those rules, right? Another one, there's an additional one. You cannot choose experimental data. You know that in the table, before using the graph, before drawing the graph, in a table you get x and y coordinates. But you cannot use experimental data on these x and y coordinates, right? Because you only have to use a coordinate on the graph on this line, right? So what are the rules? The coordinate must be on this line and they must be furthest away. Another one is it has to exactly go through one of these intersect, right? One of these crossing exactly has to go through crossing. So once you regard all these rules, there might be only two coordinates. So in the exam they ask, right, what are the two coordinates that you would get in order to find the gradient? So if you choose a closer gradient, I mean closer 2 points, let's say you choose these 2 points, but you won't get the marks. You must get these 2 points. There can be like, for in some cases there can be like four coordinates, but all those coordinates has to follow these rules, right? Otherwise they are not going to give you marks. Still you will find the gradient, but you have to get the first, they ask the coordinates, right? So they specifically say in the marking schemes only give marks to who have taken those two coordinates, right? In many cases that is the case. That is the case in many questions, but there can be like four coordinates as well in some questions, right? Yeah, so you have to be careful there. Yeah, so the answer is going to be the first one. So at the first option, the coordinate set is the correct answer. So x is 16, 13. That is one coordinate. And the coordinate 39, 31. So these are the two coordinates that you are going to use to get the gradient. Right. Third question. Periodic time of a pendulum is given by t equals 2 pi L over G, right? L is the length of the pendulum. L is the length of the pendulum. G is the gravitational acceleration. If you are given to find G experimentally, if you are given gravitational acceleration to be found experimentally, what are the appropriate quantities that you are used as x and y coordinates in order to get a linear graph, right? So this is another types of question they ask in the exam. So if you already have learned simple harmonic motion, so this is one of the use. But without learning simple harmonic motion as well, if you have a basic understanding of the graphs, you will understand this question. So without having a clear understanding of these, it is not possible to learn physics, right? So you must understand these, right? So when you need a linear graph, you have to form whatever the equation given into a y equals mx plus c form. So y equals mx plus c is linear, right? So you have to form this into that form, right? Y equals mx plus c. There might be, c can be 0, right? Let's see. So they ask you to find G, right? G. Here, the length, x and y coordinates. So here what we are going to do is we are going to change the length. So, and with length, time period changes. We know that G does not change, right? So, you know, simple pendulum, something like this, then it oscillates like this, right? So the time period is the time required to complete a one cycle. So that changes with the length, not the gravitational acceleration. Gravitational acceleration does not change. It's just 10. So with length, so length is the independent and t is the dependent. Those should be related to dependent and independent, right? Okay. But let's say, so as y, you just put t there. For t, you put y. 2 phi, as L, you put x there. You know, root means to the power half divided by g half. So this 2 phi divided by g half, this is can be the gradient of the graph. I mean m x half y. So do we have the y equals mx plus 0, y equals mx in this way? We don't, right? What do we have? Y equals mx to the power. The power here must be 1 if you want to get a linear graph. So what do? We have to somehow make this a 1. Right? We cannot have other powers here. Right? So this method is not going to work. This is not going to work. In this way you won't get a linear graph. But we need linear graphs since they are convenient. Right? So we are going to use a trick here. So I'm going to square both sides of the equation. I'll square 4 phi squared L over G, right? So the constants, I will take that to a 1 within a 1 bracket. Then there's L. T squared is like this. So I form it like this, right? Then what I'm going to do is for the T squared, for the whole thing, I'm going to put Y. For this one, I'm going to put X, right? So what do we get? So instead of T squared, I just put Y. There's this gradient, right? It is just consisted of constants, doesn't matter. Then length is just Y, X. So what do we have? Y equals mx. There's no power, both are 1, right? So we'll get a graph that goes through 0, 0. So that is y equals mx graph, right? So with these graphs, it is easier to find the gradients and other stuff, right? You can easily use this graph once we get a linear graph. So the trick here is we just manipulate this equation into a form that is y equals mx. Then we choose variables so you can form y equals mx like this. So you have to practice this one, right? So this is like very important when it comes to experiments. Not only for these parts, we will have experiments from the whole syllabus. So oftentimes you have to do this. When you get an equation, you always, not always, I mean, mostly, in most cases, you have to convert that equation into a y equals mx plus c form. So you have to practice this, right? Okay, so the answer they are going to be second one, right? So the x coordinate, you have to get x coordinate as L, simple L, y coordinate as t square. Not the coordinates, I mean axis. X axis is L, y axis as t square. Get it? if you get y as t and x as L over 2, L root and t, then you wouldn't get a linear graph. You have to use this one in order to get a linear graph. There's another way as well, but since you have to find the square root, it will be somewhat complicated. Let's say you get this one y as capital T and root L as x. This answer is also correct. Let's say you took x as L root and y as T. So for whole L root, you can substitute x there. Then again you will get a linear graph. But it is a bit difficult to work with the roots. That's why we just square both sides and choose these as the x and y axis. This is as independent variable and this is as dependent variable, right? Okay. So if you don't understand at once, please rewatch this, right? So these are basic concepts that you must understand if you want to gain marks, right? Right. Fourth question. A car A stops at a traffic light and it starts moving. Once it is turned green, right? So when it is turned green, car A starts moving, right? So let's say from here, actually, according to the graphs, car A has the acceleration, double arrows. At the same moment, car B moving at constant velocity passes A. Then car B, it has a constant velocity. Doesn't have acceleration, it only has a constant velocity. So the car B has a constant velocity 30 meters per second, according to the graphs, right? A starts at rest. So what happens? Obviously, car B passes, car B is in front of car A, right? Because this already has a velocity. This has a zero velocity, but its velocity is gradually increasing, right? So car B is somewhere here. Car A is gradually increasing its velocity due to acceleration. Then it is behind, right? Car A is behind car B. It will pass somewhere here. Car A will pass car B somewhere here. Because this car A is having a constant acceleration, so it will eventually gain the required speed in order to pass car B. Car B only has a constant velocity from the beginning, right? So this is explained in the graphs. So this is a VT graph, velocity time graph. So as you can see, for the car A, its speed is gradually increasing. So it has an acceleration. Since it is linear, acceleration is constant, right? I have to explain that as well. So gradient of VT graph is what? Always acceleration. Gradient of a VT graph is acceleration. So this is the equation you have to remember when it comes to VT graphs. Very important equation, right? Gradient of VT graph is always acceleration. So whatever happens to the gradient happens to the acceleration. So here you can see gradient is constant. See that? It is linear. If you go along this line, it is constant because it is linear, right? I'll show you what happens if the gradient is, let's say like this. You have a graph like this. Just draw a tangent to each point. What happens to that tangent? If you draw tangent, that alpha angle is increasing, right? This alpha, as you're moving along the graph, alpha is increasing. So meaning of that is gradient is increasing. If it is a VT graph, if gradient increases, meaning gradient means acceleration, right? So acceleration increasing. If you get a shape like this, okay? But since the then I'll explain gradient decreasing as well. Let's say like this. What happens now? Gradient, just draw tangent. It is lowering, right? Gradient. Just think about like a slope of a mountain. So when you go along this line, what happens? That slope is decreasing. When you go along here, slope increasing. Slope increasing, here slope is decreasing. Okay? So that is very important, right? I'll explain this again at the another questions. Anyway, for this one, if we go along, we have a constant slope. Gradient is constant. So constant acceleration. It is not that useful for here. Here what is useful is to get the area of VT graph. So I think everyone knows this. Area of a VT graph is provides us displacement. Area of VT graph gives us displacement, right? So this is graph A, this is graph B. So if A passes B somewhere here, what should happen? The displacement of those two should be equal, right? So we don't know where it is going to be equal, but let's say at time t, the areas is going to be equal, right? Okay. We have to find this time where the areas is going to be equal, right? So let's take, so I just put t here. I'll write this height because I need to find the area of this triangle. I'll write this side in terms of t. It will be useful later. So I'll just go for tan alpha, right? When you consider this whole triangle, that is OCA triangle, tan alpha is what? AC divided by OC. AC divided by OC. So AC is what we need. So we have T here, just cross multiply. T tan alpha. So we have a term for AC, that is AC is equal to T tan alpha. Another thing you need is tan alpha is acceleration, right? So let's see whether we can find acceleration here. In order to find the acceleration, you need to get the gradient. Okay? Right. To find acceleration, so how do we find the gradient? This length, this y coordinates difference divided by x coordinate difference. That's provides as a tan alpha, which is the gradient. So tan alpha is what? That is the acceleration, right? Tan alpha is this side. What is this side? 30. See this? 30 is this side. That is the opposite side. And the adjacent side, this one, if you observe that this value is 4. So 30 divided by 4 is the tan alpha. So we know tan alpha. So T times 30 divided by 40. That is going to be AC. Right. If you want, you can simplify this. 15 divided by 2. So AC is 15T divided by 2. Right? Once you understand these concepts, these are not that complicated, right? But since I'm explaining these at once, it will be too much for some students, right? Right. Somehow you have to understand, these are like key concepts, right? Okay, so we know AC, 15t divided by 2, this is AC, right? So as A passes B, what should happen? Area of this one, OCB, let's say this is D, OCBD, that is the graph for B, should be equal to this triangle, OAC, OAC triangle, right? OCBD, that is easily can be found 30 times T. Then OAC, that is a triangle, so half this side T, height is 15t divided by 2. Then T cancels off from both sides. So here we have 30 and you can cancel with 15, 2, 2 to 4, cross multiply becomes 8. So the time is 8 seconds, right? So that is what it means. This T should be equal to 8 seconds. So at 8 seconds, the car A passes car B. Car A passes car B. So the answer should be second one, right? Answer should be second one. So this is a MCQ, it doesn't take this much time, right? So if you are very familiar with graphs, it doesn't take that much time actually. It only takes like 10 seconds to find this. Because 4 is here, as you can see, this area and this area should be same. This is common area for both graphs. If this area needs to be same, what should be this length? This length should be 4, right? So 4 plus 4 is 8. So easily you can find that if you are very familiar with graphs and you clearly understand this. But the purpose of explaining this is to give you a brief understanding of gradient and the areas of graphs, right? Fifth question. Displacement time graph of motion of an object is shown below. So this is a displacement time graph. So they are asking about which options are correct, right? They are asking about options correct, right? The thing is, it is somewhat complicated to think about acceleration using a displacement time graph, right? You can directly find the acceleration. It is you would have to think a bit harder, right? So the easiest way to do this question is you just have to convert this whole graph into a VT graph, right? Whole thing into a VT graph. Then from the VT graph you can think about acceleration, right? Then it will be easy, right? So in the first part they ask T2 and T4 direction of velocity changes. T2 and T4, here and here. They are asking whether the direction changes. Actually we can find that, but it is better to convert this whole thing into a VT graph first, so we can easily get the answers required, right? So before converting this into a VT graph, you have to understand this. What is the combination between displacement and velocity? So we are going to convert this into a velocity graph. What's the combination between velocity and displacement? Gradient. So velocity is equal to gradient of ST graph. ST graph. So velocity is equal to gradient of ST graph. Gradient of ST graph, right? Clearly you have to understand that. Velocity is equal to gradient of ST graph. So whatever happens to the gradient, happens to the velocity. They have the same behavior. So if gradient is increasing, velocity is increasing. If gradient is decreasing, velocity is decreasing. If gradient is positive, velocity is positive. Gradient is negative, velocity is negative. Right? Okay, let's see. First, we'll get this from 0 to t1. From 0 to t1. From 0 to t1. So what happens to the gradient? What happens to the gradient? T1. So I told you that gradient is a slope, right? So other thing is to this side, gradient is always positive. To other side, gradient is always negative. To this side positive, to other side it is negative. Positive, negative. So here what is the gradient? To this side, right? So it is positive. Positive gradient is decreasing. See that? Can you see that? Slope is decreasing, right? As you are going from 0 to t1, slope is decreasing. Meaning gradient is decreasing. I'll say m, gradient. So positive gradient, so m is positive and positive gradient is decreasing. These are positive gradients all the way from 0 to t1, right? And that positive gradient is decreasing. Slope is decreasing. So you have to first figure out whether it is positive or negative. So it is positive and positive gradient is decreasing. What does it mean? Positive velocity is decreasing. That's what it means. So we need to have a positive velocity here. Here displacement is 0, but since it has a gradient at this point, it has a positive velocity. So just mark the initial velocity as here. We are plotting gradient at each point, right? And the gradient here is 0. Here gradient is 0. Positive gradient is decreasing. Like this. See that? Positive gradient is decreasing, so positive velocity is decreasing. So whole from here to here, velocity is positive, but it is decreasing. That's it for that. Then we'll think about from here to here. From here to here, if you draw a tangent, what's the sign of that tangent? It is negative, right? See that? Negative, that tangent is negative. Negative gradient is increasing, right? See that? If you go through here, it is slope is increasing. So for this part, gradient is negative and it is increasing. So what should happen to the velocity? Velocity is negative. Velocity becomes negative, but it is increasing, right? Value is increasing. See that? Values are negative, but it is increasing. Right. Then for this part, next part, from here to here. What about the slope? If you draw a tangent, is it positive or negative? To this side, negative. This side, negative. Is it increasing or decreasing? It is decreasing. See that? Slope is decreasing. So what should happen to the velocity? Negative velocity, and you have a decreasing velocity. Same thing happens to the velocity, right? Negative velocity, and it is decreasing like this. See that? The magnitude is decreasing, negative values are decreasing. Okay, then next this part. So what happens here? First think about the sign of the gradient. So if you draw a tangent, it is like this. So it is positive. positive tangent, actually it is from 0 to here, positive tangent is increasing, right? It goes like this. Slope is increasing. So positive gradient is increasing. Positive gradient is increasing here. It doesn't matter this graph is above or below. You only have to think about whether the gradient is to this side or this side. Then think about whether the slope increases or decreases, right? You can rewatch this and try yourself what I'm telling you, right? So you can convert any graph into a VT graph, any displacement time graph. Okay, here we got positive gradient and it is increasing like this. Positive gradient and it is increasing. So this is the correct VT graph, right? You have to do this on your own actually. Once I explain this, you have to do this on your own and try that, right? Right. Now let's think about these times, the options given. T2, T4. So once you get used to this doesn't take that much time, right? But to explain it takes time. Right. So in the first option they say T2 and T4 velocity, direction of velocity changes. T2 is here, T4 is here. Velocity, direction of velocity changes. Here gradient does not change, so it just keeps going like this. No, it is decreasing, velocity is decreasing, but the positive velocity is decreasing. So it will be like this. Positive velocity, but it is decreasing. So the graph, VT graph would be like this. First they ask at T4 and T2. T2 is here, this point, and T4 is here. Direction of velocity changes. So we know positive, so if we have a velocity, right? Let's say velocity to this side. If the object moves to this side, velocity is positive. If the object moves to the opposite side, velocity is then negative, right? Direction changes when it is a negative velocity. Velocity has to be a negative velocity if the direction needs to be changed. So at which points does that happen? At T1. See that? Velocity transfers from a positive value to a negative value. So at this point, direction of velocity changes. At this moment, the object starts to move to the opposite direction. And another point is here, T3, it goes from a negative velocity to a positive velocity. So the direction changes. Get it? So whenever the velocity takes the another sign, direction of the velocity changes. Right. Then what happens here? T2 and T4, what about T2? At this moment, here and here, velocities at both moments, before and after, from T2 moment, velocity is negative. So the direction does not change, hasn't changed, right? At T2 it doesn't change. And if you think about T4 as well, at both moments, before and after, velocities is still positive, meaning they are moving to the same side still, same direction. So A is not correct. A is not correct. Then B. At T2 and T4, direction of acceleration changes. Direction of acceleration. Meaning you have to figure out whether the acceleration is positive or negative. If acceleration is positive, so the acceleration is to one side. If it is negative, opposite side. So from these graphs, you have to figure out what happens. So using the VT graph, it is easy to find. And they say at T2 and T4. What about T2? T2, before T2, So in the VT graph, acceleration is given by the gradient, right? Gradient is like this. So we have a negative gradient before T2, then positive gradient. So here the acceleration is negative, here the acceleration is positive. See that? So at T2, direction of acceleration has changed, right? Another one, T4. Here the acceleration is what? To this side, acceleration is positive. And at the other side, to this gradient, acceleration is negative. Here positive, here negative. Got it? So at B is correct there, right? B is correct. Then C, T2 and T3 acceleration is 0. So for the acceleration to be 0 in a VT graph, it should be flat there, right? Nowhere in this VT graph we have a flat line. Flat line means like this, horizontal side. Everywhere there is a gradient, right, for the VT graph. See that? So think about this now. Let's think, like, if you think only this using displacement time graphs, then it is going to be like very complicated, right? If you didn't convert this graph into a VT graph. If you have a good practice in dealing with graphs, you can do that using a displacement time graph as well. But if you don't, first you have to convert this into a VT graph, then figure out that. Because thinking about acceleration only using a displacement time graph is somewhat complicated, right? You need to have a higher practice in dealing with graphs there. That's the reality there, right? So you need to, many students finds that graphs hard, right? To have a correct understanding of graphs, you must have a practice. Practice is what makes this understand. You will have to do even the same question again and again if you want to practice, right? That's the only way, right? That's the only way you can get these into your brain, right? Once you get these concepts, then it is nothing, right? It feels like nothing once you understand these questions. But before that, you might find these complicated, right? Right. Sixth question. A ball free falls from rest, hits the ground perfectly elastically, and bounces off. Then it again comes to instant rest. The graph that rest represents the motion is, right? So a ball, initial velocity of the ball 0. So the ball falls down at 10 meters per square second, right? That 10 meters per square second, that is gravitational acceleration. So this starts accelerating and hits the ground. Let's say the ground is here. Hits the ground, let's say at V. Then they say it is a perfectly elastic collision. What does it mean? It means, if you learned well the energy conservation, perfectly elastic collisions means there's no mechanical energy loss in a perfectly elastic collision. So if there's no energy loss, as it bounces off also, we'll have the same speed, right? So if it has the same speed, it can reach here to the same height, right? Falls down, bounces off, goes to the same height, right? So this is what happens. So you have to draw the graph for this one. So so here I can explain from the fundamentals, right? If you couldn't understand the previous ones, here I can explain from the fundamentals. So when you are drawing a graph, first thing, you need to have an origin. Origin is here. Where the motion starts is the origin, right? So you define the origin. Then you have to define a positive direction. The positive direction can be any direction. It can be upside as well, upwards as well. Usually we take positive direction to be the direction that objects starts to move, right? So I'm choosing positive direction to be downwards. You can choose upwards as well, right? So you have to get the correct graph there. They're asking for the most suitable graph. Anyway, we are choosing the direction to be downwards, positive direction. Right. So once you define the positive direction, anything to this direction, anything means any vector to this direction is positive. If any vector is to the opposite direction, then it is going to be negative. Okay, they are asking about VT graph. So when it comes to the VT graph, gradient of VT graph is equal to acceleration, right? So initial velocity, it is 0, it starts from 0. So graph starts from here. Okay. Then it falls down, velocity is increasing. What about the acceleration? It has a constant acceleration, right? It just falls down at 10 meters per square second. So if it has a constant acceleration, gradient also should be constant, meaning it should be linear like this. And the velocities are positive, right? See that? Positive direction is downwards now. In other cases, if you shot the object upwards, usually take the positive direction to be upwards. But here I took as downwards. You are free to choose any direction, right? Usually you take the direction of the initial velocity to be the positive direction, right? So here it hits the ground at V, then bounces off. As it bounces off, what happens? At this instant, as it bounces off, direction of velocity changes. Now what is the sign of this velocity? Magnitude is the same as this, but direction has changed. So it is upwards, so it should be negative, right? Because this vector is upwards now. So negative V minus V, right? So I'll just start here. Then what about here? Then it starts to go up, and here it will be 0. So velocity has to be 0. Somehow the graph has to go here, right? Again, as it goes up, what's the acceleration? It's always 10 downwards, not minus 10, right? It goes up. It doesn't matter whether it goes down or up. Acceleration is always downwards. Acceleration is always downwards, right? Meaning acceleration is to positive direction. It is downwards, so positive direction. Positive direction, if it is a positive gradient and constant, graph should be like this, right? So this side is positive always. It doesn't matter whether it is above time axis or below t-axis. This is positive gradient. So in both cases, gradient is the same. See that? Gradient, sign of the gradient is the same. It doesn't matter whether it goes up or down. Gradient is always 10 meters per square second. Its direction does not change, neither its magnitude, right? So the gradient is the same. So you have to choose a graph similar to this one. So what is the graph there? Third one, right? Third one. Right, seventh question. Graph below shows the variation of acceleration of an object with time. Right, so they have given an acceleration time graph. So what they ask is the correct graph, correct VT graph, velocity time graph for this one. So before that, you need to get the combination between acceleration and velocity. So as you know, acceleration is what? Acceleration is equal to gradient of VT graph. Okay, so whatever happens to acceleration happens to the gradient of the VT graph. Meaning acceleration could be positive, so the gradient should be positive. If it is negative, acceleration, gradient is negative. If acceleration constant, gradient of VT graph constant. Right? Okay. So below that, I'll draw the VT graph. Right. So for the first time period, this time period, acceleration is constant. Acceleration is constant. So the gradient should be constant and also it is positive. So how do we draw a positive gradient and constant? Like this, right? So you can draw it like this. Positive gradient and constant. Then at the next part, here the acceleration is a higher value. Acceleration is a higher value. So the gradient also should be a higher value. Meaning slope has to be a higher value but constant. Let's say like this. Right? Then this part, negative acceleration but a higher value. Negative acceleration means gradient also should be negative. And also it is a higher value. So negative, higher gradient, constant, right? So gradient to this side is negative. This side is negative and also it's a higher gradient. Slope is higher. Then this is negative acceleration, meaning slope should be like this, but it is less value. So slope is less. Right? So the shape should be like this. So everything has to do with those gradients, right? Gradients is the main concept that you have to understand for these conversions. So anything happens to that happens to the gradient. Or in the another way, anything happens to the gradient happens to the quantity, right? So here we in a ST graph we considered gradient of a ST graph is velocity. Gradient of a VT graph is acceleration. Those are the only two gradients that you have to consider for these conversions. So the answer should be the second one there. Right, eighth question. Velocity time graph of a particle is given below. D1, D2, D3 are distances traveled within T1, T2 and T3 time periods. The graph that best describes the variation distance time is, right? So this is not displacement time, this is distance time. So distance time means it doesn't have a direction. So you only have to consider about the magnitude, right? So let's see what it means. So the combination between distance and velocity is like this. You know, velocity is equal to gradient of dt. Okay. So here velocity, actually it is magnitude of velocity, because you have to get a distance time graph. So you only have to consider the magnitude of velocity, because velocity here is always positive, right? We only have positive velocity, so you can consider this to be just speed. Doesn't matter, right? right? So speed is gradient of dt graph, distance time graph. Here the speed is constant. So whatever happens to speed happens to the gradient. Speed is positive. It's obviously always positive, right? Doesn't become negative. So the gradient also is positive and a constant. So gradient also constant and positive. So positive gradient is like this and constant. Let's say like this. Positive gradient and constant. Okay. So once you complete here, it has reached D1. See, this area is D1. So the distance it has traveled after T1 time period is D1. Then speed increases. Speed increases, so the gradient should also be increasing. So it doesn't remain constant. This is positive gradient, right? Positive means like this. Positive this. And it is increasing. Get it? Slope is increasing, right? Not like this. This is decreasing. So the shape should be like this. Increasing slope. Increasing gradient. So it should be increasing like this. Up to here. Then what happens? Speed is decreasing. Speed is decreasing, so the gradient should be decreasing. Gradient is decreasing, right? Like this. See this? Think about the slope. Slope is decreasing. It doesn't come back, right? Because it is always positive velocities. In both cases, velocity is always positive, but the gradient is changing, right? In this part, gradient was increasing, another part gradient was decreasing. It becomes 0 here. So here the distance travel should be d2. Sorry, d2 plus d1 actually. d1, this thing d2. Only from here to here it is d2. So this should be d1 plus d2. Then d1 plus d2 plus d3. Okay. So I have to add these three. Okay. So the answer should be third one for the 8th question. Right. 9th question. So we have given a graph there. Velocity time graph for a train is given below. So it is a train. So this graph explains the velocity of a train. Within T1, T2 and T3 time periods, distances traveled by the train are 3, 11 and 2 kilometers. Maximum velocity of the train is. So here we have the maximum velocity. Let's say capital V, right? Maximum velocity. So they're asking for the maximum velocity in kilometers per hour. So for this graph, you just have to convert everything into kilometers and hours. So 36 minutes, I just converted into hours by dividing by 60. So it becomes 0.6 hours. So using all this data, you just have to get some equations, and by solving them, you can find a value for V. That's all you have to do here. So considering this triangle, I can get this one, right? VT1, T1V divided by 2 equals 3 kilometers. So what do we get? VT1 equals 6. T1 equals 6 divided by V. T1 equals 6 divided by V, right? Because the area of VT graph is just displacement, right? Displacement here is 3 kilometers. It is given. Then this rectangle, what is that? VT2. VT2, that is 11. Then I am getting an expression for T2 time, that is 11 over V. So I am writing these times in terms of V, right? So this is the easiest way to do this. That's why I am following this method. Then this triangle, that is V T3 divided by 2 equals 2. So T3 is equal to 4 divided by V. So I have all the times in terms of V. Another one, you know this one, T1 plus T2 plus T3. That is just 0.6, right? 36 minutes. In hours it is 0.6. Then I can substitute these values for T1, T2 and T3. So T1 is 6 over V, T2 is 11 over V, T3 is 4 over V. Denominator 6, 17, 17 plus 4, 21 equals 0.6. So cross multiply, V equals 21 over 0.6. 7 divided by 0.2. 0.2 means 1 over 5, right? So as it goes up, it becomes just 5. So 5 times 7 should be 35 kilometers per hour. It is just a simplification, right? It is not that complicated. You just have to get a bunch of equations, and but the simplification you have to do it this way, otherwise it will get complicated, right? To find this maximum velocity. So the answer should be the third one there. Right, 10th question. Image shows the variation of acceleration time of a particle. If the particle starts moving from rest, the maximum velocity gained by that particle is, right? So for an AT graph, the area of an AT graph, what does it give us? Area of an acceleration time graph? It gives us velocity, not just velocity. You have to carefully remember that it is change of velocity, right? Not just velocity, it is change of velocity. If here it is u, here it is v, this should be v minus u, okay? But if u is 0, initial velocity is 0, then we can consider that area is just velocity, right? So for this part, let's find the area. 2 times 1, 2, here 2 times 2, 4, but it is minus 4, right? Here 1 times 2, 2. They say initially this is at rest, so the velocity should be 0 initially. Then after, if the change is 2, so it has to increase by 2. 0 plus 2, so it is plus 2 meters per second here. Within this, there's no acceleration, so there's no change of velocity. Here at this moment also, it is plus 2 ms minus 1. It doesn't change, right? So here also plus 2 ms minus 1, because there's no time spent. Plus 2 m. Then after here, you have to add minus 4 to this velocity to get the velocity here, because that's a change there. So plus 2 minus 4, it is minus 2 ms here, right? From here to here, it is minus 2 ms. Here also minus 2. Then this is a positive area, so you have to add that to -2. So it becomes 0. Here the velocity is 0. Right? So at each point, so likewise you can find the velocity at each and every point of the acceleration time graph. If you want, you can draw a diagram, VT diagram, but it's not necessary, right? If you want, I will draw that, just a VT diagram. It is not necessary. So initial velocity 0, here the velocity 2, here constant velocity. 0 acceleration means constant velocity. Then velocity is +2 goes to -2 at here. So it should be a negative acceleration, meaning gradient is negative. Here it is 2, here it is -2. Then within this range, 0 velocity, 0 acceleration, meaning velocity remains the same. Velocity remains the same here. Then positive acceleration, meaning positive gradient. To this side, gradient is positive, right? So this is the graph. Velocity time graph is this one. So here it is shown a acceleration time graph. You have to redraw these and practice these, right? If you need to get an in-depth understanding of these, right? You have to do these on your own as well once you understand these, right? So according to this, it is clear that the maximum velocity of this can achieve is 2 meters per second, right? 2 meters per second. So the answer is third one. Right, 11th question. Graph shows displacement time graph for motion of a particle. Consider the sentences below about its motion, right? The only reason that you would get mistaken this is you will consider this to be like a VT graph, because this is one of the most common velocity time graphs, right? But to mislead you, they have given this shape, but it is a displacement time graph in reality, right? Let's consider the first option A. Within T0 to T1, particle moves at constant acceleration, and within T2 to T3, particle moves at constant velocity. So T0 to T1, here to here, they say particle moves at constant acceleration. This is a ST graph, right? If it is a VT graph, then has a constant acceleration. But this is a ST graph, so it has a constant gradient. So gradient of ST graph is velocity. So the velocity is what? Constant there, not the acceleration. So it is wrong, right? It doesn't matter the second part is correct or not. A is wrong. Then B, particle is at rest at T4. T4 meaning here, they say the particle is at rest. You can see that displacement is 0 there. At T4 displacement, this is a displacement time graph. So displacement is 0. Displacement 0 doesn't mean velocity is 0. Velocity in ST graph is gradient, right? So there's a gradient to this ST graph at this instant. There's a gradient. Gradient is not 0. Gradient is what defines the velocity in ST graph, not the displacement. So there's a gradient at this moment, right? So there's a velocity. Velocity is not 0 there. So B is not correct. C, within T0, T4, distance traveled by particle is equal to the area of the graph. T0 to T4, they say that distance traveled is equal to this area. Is it? No. It is equal if this is a VT graph, but this is a ST graph, right? So C is wrong. D, there's no D. just A, B and C. So all A, B and C are wrong, right? So the fifth one is the answer there. Fifth one. Right. 12th question. When a person drops object A from a height, so person drops, meaning initial velocity 0. Another person throws object B, throws means there's an initial velocity, non-zero initial velocity, downwards. The image best describes the motion of these objects is, right? So you can consider, I'll just describe this a bit more, right? There are easy ways to get just the answer, but I'll just explain this. So here all the graphs are positive, right? Gradients of all the graphs are positive. So clearly they have taken a positive direction to be downwards. So anything to this direction is positive. Anything means any vector. Another opposite direction negative. Let's keep drawing this. First I'll draw for A. First think about initial velocity. For A it is 0. For B there's the initial velocity initially. And it is positive, right? Downwards. And it is U. Once they are given, after that moment, both are under the gravitational acceleration. Understood? And the gravitational acceleration downwards, so it is also positive. So this is the gradient, right? So the gradient also should be positive, because acceleration is gradient of VT graph. So do you understand that for both, acceleration is 10. So for both, gradient should be same. This one, this also should be same gradient. This is the correct graph there. So it should be first one, right? First one. Right. 13th question. Image shows the variation of velocity of a particle with time. The graph that best represents the variation of displacement with time is, right? So this is a good question. You can understand this conversion. Actually, this is an exam question. So to get the correct answer, you must have a great understanding in gradients, right? Right. So the velocity and displacement, what's the combination? So I have to convert the gradient, right? Gradient of ST is equal to velocity. So anything happens to the velocity happens to the gradient, right? So let's say M for EC, M and V, right? First part, velocity is increasing. I'll just write this another way. Here velocity is gradually increasing, linearly increasing. So what should happen? Velocity is increasing. And it is positive, right? Positive. First find the sign, it is positive, and positive gradient is increasing. How do you write? Like, positive means to this side, and this slope has to increase. From 0 to here it is 0, slope is 0. Then it increases. Like this. Got it? To a certain value. Then here velocity remains constant. If velocity is constant and also positive, gradient also should be constant, not 0, right? Velocity is constant and it is a non-zero constant. And gradient also should be a non-zero constant. So if it is gradient is 0, it is like this, but it is not 0. Gradient, it has a value. It has a value not here, right? So it is a constant like this. This is a linear part. This is curved. This is linear. Now we are here. Then velocity is decreasing. Velocity is decreasing. Still it is positive velocity, right? Velocity is positive here, but it is decreasing. Sign is positive, but positive one decreasing. Positive means graph should be to this side, but it is decreasing, right? If it is decreasing, shape should be like this. See this? Decreasing. Slope is decreasing. Like this. And it becomes 0 here. Okay. Only linear part is this one. It is not that clear. But this is linear. Other two parts are curved. Or okay, then velocity becomes negative. This is negative velocity but increasing. Okay, velocity negative, so the gradient also is negative. And the magnitude is increasing, right? Negative. I mean, negative, but the magnitude of that is increasing. Negative means now the slope should be like this, but it is increasing. As you go along here, increasing, right? Slope, not the value. Slope is increasing. Negative and increasing. So it should be like this. If it is decreasing, it should be like this, right? Like this. But it is increasing now, like this. Then this part, negative velocity. Negative velocity, and gradient also should be negative. The value is decreasing. So negative and decreasing. Meaning slope is decreasing, gradient is decreasing. See this? To this side, velocity is, gradient is negative. To this side, gradient is negative. This side positive, right? This side negative, and it is decreasing. See this? And it becomes 0 here. So at this moment, the line should be flat, horizontal. Something like this. So it is ST. Got it? It cannot reach here or go below. The reason is the displacement here is higher than displacement here. It is obviously, you can see that, right? Displacement is higher here than here, right? So the negative means the displacement, that is this negative velocity means it is coming back, but the comeback displacement, the displacement that came back is less than displacement move forward. So the displacement, final displacement, cannot be negative value or 0. It should be a positive value, final displacement, right? So the answer should be fifth one, right? So they have checked everything. To get the correct answer, you have to have a 100% of understanding of how to do these conversions, right? So these types of questions you have to do again and again to practice. පොඩ්ඩක් ගහන්න මේ තව ප්‍රශ්න දෙකක් තියෙනවා. ප්‍රශ්න දෙකයි තියෙන පොඩ්ඩක් ඉන්නවා. විනාඩි 10ක් ඉන්නවා. Right, 14th question. Image shows an object projected making an angle theta with horizontal under gravity. So this is a projectile, right? Like this. The UH and UV are horizontal and vertical velocity components of the projectile. The image that shows the correct variation of those velocity components are. So you know that to this direction, horizontal component is always constant, right? Horizontal component always constant, doesn't change. Vertical component behaves as an object projected upwards, goes to 0 and comes back. This happens under gravity, right? So if you draw these on a VT graph, the variation of UH, it is a constant, doesn't change. UH means a horizontal component, right? Doesn't change. If we already have done projectile motion now, right? So UH is constant. VH, if you think about, it goes up. Let's say positive direction is upwards. Gravitational acceleration downwards 10. So this is a negative now, because this vector is downwards. This is a negative, so the gradient also should be negative, like this, right? So the answer should be fifth one for that question. Fifth one. Right, 15th. Car with mass m is subjected to constant net force. Let's say this is the car, mass m, constant net force, let's say that is capital F, and its momentum is measured at different time intervals. The data is plotted on a graph with momentum p on the y-axis and t on the x-axis. The resulting graph is a straight line. So at the end you have to get a straight line, right? What are the quantities given by gradient and intercept of the graph? Right. Due to this net force, let's say it had an initial velocity u, but it increased to v. It accelerated into velocity v due to this force, unbalanced force. Okay, so that is the case. So regarding all these, you just have to think about an equation there. Then you can convert that equation into y equals mx plus c form. This equation f equals mv minus mu divided by time. So this is f equals ma, right? Let's say initial momentum, this is initial momentum p naught, this is final momentum p. So f equals p minus p naught divided by t. Then ft equals p minus p naught. Then p is equal to so here p should be on the y-axis, right? So you have to subject p. So you have ft plus p naught. So p is equal to ft plus p naught. So since they say momentum, p is the momentum of the object at a certain instant, so p should be at the y-axis. Then this should be, time should be at the x-axis. They say in the question. Then we have mx plus c. So when you compare these two equations, gradient should be the net force. Intercept should be p naught, means initial momentum, right? So c is equal to p naught. Right? Get it? Gradient is net force. Intercept is p naught. Intercept is p naught. So the answer should be third one, right? Net force and p naught. So when they provide an equation, or you already know the equation, you should be able to form that equation in y equals mx plus c form to draw the graph. Then once you get the data and draw those things, then you have to find the gradient and intercept. everything has to do with gradients and intercepts, right? In all the experiments you are doing, you just have to get the gradient and intercept. That's all you have to do. Once you know those two, you can find those unknown quantities or experimental values experimentally with more accuracy, right? So that's the only reason we use graphs, right, for experiments, to increase the accuracy of our experimental findings, right? Okay.